A dust cloud the size of a star formed by the massive asteroids colliding. NASA telescope spotted debris cloud forming hundreds of light years away from us. Data from a retired NASA Space Telescope revealed the disaster scene left behind by a cosmic collision of massive asteroids. NASA's Spitzer telescope observing the debris cloud size suggests that the dust was formed when two bodies the size of dwarf planets smashed into each other a few hundred light years away from us. They said, by looking at dusty debris disks around young stars, we can essentially look back in time and see the processes that may have shaped our own solar system. This is what lead author Kate Sue explains, a planetary debris risk researcher and research professor of the University of Arizona. She said in March 18th statement from NASA's Jet Propulsion Laboratory in California, which operated Spitzer. The new study represents the first successful effort by astronomers to observe a debris cloud as it passed in front of its parent star, which was called HD 166191. The star's size and brightness, along with the debris cloud observations, allowed astronomers to estimate the size of the cloud, along with the size of the possible impacting debris. The objects. Now, Spitzer retired in 2020 after about 17 years of gazing the universe in infrared light. Infrared allows astronomers to peer through dense dust clouds that obscure our ability to see what's happening using visual wavelengths. HD 166191, that star neighborhood, is full of debris, in part because the star is relatively young, just 10 million years old, and compared with the sun's 4.5 billion years, dust left behind by the young star's formation is now clumping together to create planetesimals, the possible seeds of future planets, as what JPL calls them. But once gas begins to get in between those small worlds, catastrophe can arise from collisions. Spitzer performed more than 100 observations of the star between 2015 and 2019, and in 2018, the investigators did get lucky to see this. In the middle of 2018, and as astronomers watched, that sun, HD 166191, that system began to brighten, likely a sign of higher amounts of debris, but Spitzer also caught a transit, the cloud of debris passing between the telescope and the star, causing the star to temporarily appear dimmer as you would see a cloud passing in front of our sun. Ground-based telescopes had also spotted the transits, and combining the data with the Spitzer data allowed scientists to estimate the dust cloud size and shape. The observations suggest the cloud was stretched out to something like 3 times the size of the star, but the infrared brightening Spitzer saw suggests that only a little bit of the cloud passed in front of the parent star. The rest of the cloud, unseen by the telescope, might have been hundreds of times larger than the star itself. And in order to form a cloud that big, scientists calculated that the objects collided must have been massive, the size of dwarf planets in our own neighborhood. The team compared the colliding objects to Vesta, the second largest asteroid, which is about 330 miles wide or 530 kilometers. The first collision caused a cascade of smaller crashes as well. This is what the scientists believed. Now, while the cloud began dispersing quickly and had disappeared from Spitzer's view by 2019, the author said his study may help them test our modeling and theories about how young planets grow. By looking at dusty debris disks around young stars, we can essentially look back in time and see the processes that may have shaped our own solar system, Sue said in the statement. Learning about the outcome of collisions in these systems, we may also get a better idea of how frequently rocky planets form around our sun. And the study was based on research published March 10 in Astrophysical Journal. And this is on space.com by Elizabeth Howell. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.